So, hey there everyone, this is Avinash and I welcome you all to Studby. So, I'm starting this physics series in which we'll be learning basics of physics and we're gonna start off with vectors. And this is lecture number 1 and today we'll be doing introduction. So, let's get started. So, first of all, we're gonna look how many types of physical quantities are there. Basically, there are of two types. First, scalars, and the other one is vectors. And just for information, let me tell you that there is one more type of physical quantities which you may have heard several times, and it is known as tensors. But we're not going to deal with this in this chapter, so we'll look at it later on. Yeah. Now, as we have seen that there are two types of quantities, scalars and vectors. Now, before coming to that, let me just ask you one more thing, which is, yeah, for this particular question, here a particle, suppose it is going with velocity 3 meter per second in the direction east. Okay, east direction. Yeah. Now you have to tell me that for this particular question, what would be the magnitude here, right? Yeah. Now just tell me for you. Just let me give you some options. Is it 3? Is it meter per second? Is it east direction, or is it 3 meter per second? Yes. Tell me what's the magnitude. So here the correct answer is D, 3 meter per second. Now you would be wondering why. Like, I have seen many of the people whenever I ask them like what is a magnitude in any particular question, so they just tell me that any numerical value is the magnitude. But that's partially correct actually, because if we see here, 3 is the numerical value and meter per second is the you know unit. So the correct answer, or the correct definition of the magnitude would be, it's, sorry, just a second. Yeah, so the correct definition for the magnitude would be, it's a numerical value plus unit. So you don't have to forget that there's unit as well. Like, many people underestimate this and they just leave it. Now, moving on further, like, you must have heard these terms which I'm writing right now. Like, one is distance and other one is displacement. Yeah, so you must have heard about these terms, but before, like, if I directly tell you the definition of displacement and distance, we should be focusing on the question, right? The best way to learn physics is by solving questions. So let's do it. Yeah, so if you see, just I'm giving like a question, which is, for that I have to make a diagram. Right. So, right, suppose this to be a semicircle. Okay, so my question to you is that this is, yeah, you can you just see this? Let me zoom. This is point A and this is point B. So sorry, but suppose this to be a semicircle, right? Because my symmetry is not as good. All right, we should focus on question. So you have to tell me like what is the distance and displacement for this particular trajectory or the path. Let me just give you the radius as well. The radius there is 7 centimeter, right? So just let me know What do you think? Pause the video and do it yourself, then unpause and see the answer. Yeah. So now look at its solution. So we have to find two things here. One is distance and the other one, it's displacement. So we would be starting off with displacement first, right? So in this case, before that, let me just know you that you might be knowing that the displacement is nothing but the shortest distance between the any particle or the any trajectory, or we can say from any initial point to the final point. It's the shortest distance, nothing rocket science here. So if we just see there, in this question particularly, the shortest path would be from A to B directly. And if you look at closely, as I have told you earlier, that it's nothing but the uh, semicircle. So the our shortest path is nothing but the diameter. So we all know that the diameter is nothing but 2 radii. So here the displacement would be nothing but 2r. So from this we concluded that, oh, the displacement is 2r and all that. So here if we put the value, we'll get the answer as 2 into 7, which is nothing but 14 centimeter, right? So this is the solution for, or the answer for, displacement. If you got it, congratulations. Now moving on to distance, we have to find, right? So distance is the original path, and in this question the original path is this white line which I draw here. So it's the circle, right? It's the semicircle, sorry. Now if you just see that, what would be the circumference of a semicircle? We all know that the circumference of a circle is 2 pi r. So for a semicircle it is nothing but 2 pi r divided by 2, because the semicircle is nothing but a half a circle. So it got cancelled. So the distance is nothing but pi into r, right? So if we move further, here we know the value of pi, that's 3.14, or it's easier if we take it 22 by 7, because the radius is 7, so it get cancelled. Yeah, so it's 22 by 7 to 7. So here 7 and 7 would get cancelled. So the original path would be 22 centimeter, right? This is distance. So in this particular question, we just saw that the displacement came out to be 14 centimeter and the distance came out 22 centimeter. Now, what can we conclude from these results, right? So let's just see. From this, we can, first thing which we can say is that the displacement is always less than or equal to distance, right? Why sorry for this, why equal? Because you know that the distance is the original path. So if a particle just moved in a one dimension or just like this, so here the displacement and distance would be equal, right? Because it's not two dimension or three dimension, it's only one dimension, so it would be equal, right? And it would be greater, right? Because distance could be greater than displacement, or it is most of the time, it's greater until and unless it's the one dimension. So here we got this. Now second thing, we can write it as vice versa, that displacement can never be less than distance, right? We just saw this. Here you have to just highlight this never. Okay, so we got this. Now, so we concluded this from the question and we got it. Now moving on to next one. Now let's do one more question, and it is an interesting one. So let's see. Let me the question for you. So like here I'm again giving you a path. Just a second. Yeah. Yeah, so this time this is not a semicircle, it's an arc. Okay, remember this. So let me just zoom it for you. Now here 2 points are given to you. This is given as A, and the other one here which is given as B. Now again you have to tell me the distance and displacement for this particular path. Now notice that there is no radius given, so this would be a bit interesting question. So let's see. Now pause the video and solve it and take your time. Now let's see how we can do it. So in this we have to just tell the distance and the displacement. In the previous question, if we see, the question was same but the radius was given that time, but here no radius is given, and it is not a semicircle as well, it is a sector. So it's a bit challenging. I understand, but let's just see. So in that we just did the whole easy calculation, but here let's see. So we know that the distance would in this particular question would nothing but be but this, this one, and the displacement would be this blue line which I'm drawing here, right? This would be, sorry, yeah, this would be displacement. Now we have to find it. So what can we do? So let's just complete the circle, or we should just draw sector for segment for the circle. Sorry, sector for the circle, my mistake. No, let's just this would be the radius, and this would be the another radius of the circle, right? These both are the radius. Now the angle between the radius is nothing but the theta. Okay, so let's see what can we do from this. Now we look at the figure closely. Here we can see it's a triangle, but if we divide it from the center, it would be there would be two right angle triangles. Okay, right, there would be two right angle triangles. These are the two right angle triangles here we got, and let's assume these both distance to be x and x. Now if we just see how can we solve it. Before that, let me just tell you one more thing you might don't know, that in any given circle, the arc length, the arc length which is in this condition, which is the yellow one, the arc length is always equal to, yeah, arc length is always and always equal to, remember this, radius into theta. Theta is the angle, this angle which I have drawn here. So remember this. So with this formula, with this thing, we can directly say that distance is nothing but in this case radius into theta, right? No rocket science here. Now the real challenge comes in the displacement. Okay, so we know the displacement here would be 2x, right? Because x plus x. So let's see how we can do it. Now if we take just this particular triangle which I'm highlighting here, if we take any of this triangle, like I'm taking this triangle, like this triangle, okay? So for this particular triangle, let's see what we can do. It is, sorry, yeah, their displacement is 2x, and for this particular question triangle, if we see sine theta by 2 is equal to, just wait, theta by 2 is taken because you know that these both parts would, this would be theta by 2, and this would also be theta by 2. So we are taking this one side of triangle, right? Okay, so we all know that sine theta is nothing but perpendicular upon hypotenuse. For this particular question, the perpendicular is this part, this x, okay? This x is perpendicular and the hypotenuse is this, okay? Yeah, so let's see what we can do here, right? So the here the perpendicular is x, and the this white part, it's nothing but, I have told you earlier as well, it is the radius. So it would be nothing but x upon r. Okay. Now, if we just find it by that way, the x value would come as, if we just transfer it, it would be coming as r sine theta by 2. Okay, this would be the value of r, sorry, x. And we see the s is nothing but 2 in 2x, which is equal to 2r sine theta by 2. Okay, I think you we got the answer here. So this is the answer for this particular question. Here the displacement would be 2 sine theta by 2. Okay, now let's just see what we did here. Here we have to find distance and displacement, and we did distance was the easy one because you know it's nothing but the arc length, which is r into theta. And for the displacement, we assumed the this side to be as x, and this is the radius. Now what we did, we all know that sine theta is nothing but perpendicular upon hypotenuse. In this case, the perpendicular was theta and the hypotenuse was radius, so it came out to be x upon r. Now x is nothing but r sine theta by 2. And just a second, let me just write it also capital, so there will be no confusion, right? Yes, right. Yeah. So we did it, and by just simplifying it or transferring the values, we got it as x is equals to r sine theta by 2. And 2x is nothing but, or the displacement is nothing but 2x, which is 2r sine theta by 2. So here it was pretty simple, it is the answer, right? We got it. And now moving on the to the next part. Right, so let's see. Now we are gonna look at how do we decide whether a physical quantity is scalar or vector. Okay, so this is our new heading for this topic. Yeah, so let's just see. So let's just assume I'm giving a trajectory or a path of a particle. Let's see if a particle started from point A to point B and travel to point C. Okay, so this is the path of a particle, and this, the angle here is 90 degree, it's the perpendicular. Now for this particular thing, let's do this in a tabular form. Like, let me just draw a table for you. Right, okay, let's see. Here let me mark it with A to B, and this as B to C, and this as total, which is nothing but A to C. This is the distance. So we would be solving this for distance as well as displacement, right? So let's just see. So displacement, as I told you, it's nothing but the total length or the original distance. So here let me just give you the marking as well, sorry for this. It is 4 kilometers, suppose this, and suppose this to be 3 kilometer, right? So in this case, we know from, let's just see first from point A to B. From point A to B, it moved how much? 4 kilometer. So we'll write 4 here, it would be 4. right here. Now for point B to C, if we see how much kilometer or how much distance it traveled, 3 kilometer, right? So it would be 3. Now what would be the total from A to C if we just add them? It would be 4 plus 3, it's nothing but 7, as easy as that, 7 kilometer. Okay, now for the displacement, we know that it's nothing but, you know, the shortest distance. So in this case, the shortest distance would be hypotenuse of this triangle. This is the shortest distance or the displacement. Now, if we just look at it, A to B, how much it traveled for the displacement as well, 4 kilometer, and for B to C, it again travel as 3. But in this case, the total A to C would not be 7, as you all know. It would be, as we know that it's a Pythagorean triplet. So the hypotenuse would be of 5 kilometer. So here the total is 5 kilometer. Did you notice one thing here? What that we can solve this, or we can add them algebraically. The distance we can add them algebraically, okay, and we cannot add this algebraically, or simple plus minus we cannot do here, okay. So we all know that for the distance 4 plus 3 is equals to 7, but how this did came, how the hell this came, 4 plus 3 is equals to 5 kilometer, we don't know. So we are gonna look at this, because we all know 4 plus 3 is 7 kilometer. How it could be even shorter than that? So let's see what happened here. So first, if we see for displacement, sorry, for distance it would be distance of A to B plus distance of B to C. It came out here nothing but DAC, right? And here DAB and DBC, it's first it's 4 and the other one is 3. So it came out nothing but 7. Now, if we just look at the other part, it's displacement of AB plus displacement of BC. So in this case, it would be displacement of AC. And I'm drawing arrows here. I'll tell you about them later on. You'll get to know it. Now, if we just see, it came out to be 4 plus 3. And what we got as an answer? 5. So we're gonna draw arrow sign here. We'll know what is it. And it would be I cap plus j cap. Now you just don't focus on these terms. You'll get to know them. Let me just erase the arrow. This is the wrong concept here, right? Because you write I cap and j cap. You will come to know about them later on. Now, so what can we say? These, the distance. This added. We added it algebraically, and this we added vectorially. Okay, try to understand this. So from this we can say that distance is a scalar quantity and the displacement is nothing but a vector quantity. I think you're getting it here. This is nothing but a scalar which follows algebraic addition, and here it is here it is vector, because it does not follow algebraical addition or subtraction. It follows vectorial addition or subtraction, so it's a vector. Now I think you got how do we know whether a physical quantity is scalar or a vector. Now from this, let's just see what we can say, or what's the difference between a scalar and a vector. Now let's see. Let me draw partition here. Okay, in this side we'll be doing scalar and here vector. Right, yeah. So the first difference is nothing but it follows algebraic or the arithmetic addition. In this case, it follows triangular law, or we can say vectorial addition to real addition. Yeah. So we wrote the first difference, which is nothing but how are they added or subtracted, all that. Now, the second thing is that a scalar quantity has a magnitude, but in this we have magnitude as well as direction. You have to remember that in vector we can't say that it is moving 3 centimeter or it has just traveled 3 kilometer. We have to specify the direction. As you remember that in the first question which we did, I have mentioned the east direction. So it is a vector quantity because I have given the vector quantity. So you have to remember that in a vector there is direction as well with the magnitude. We cannot just say that it is 5 kilometer or 7 kilometer. We have to specify direction. That what I meant. Now let's look at the third difference. Just a second. Yeah. Third is the difference is this: scalar may or may not have direction to solve scalar quantities. Or we can just say that direction is insignificant. Right? Yeah. So the third difference we noted as well. And for this, the third difference is that vector also have direction and to solve vector quantities. Vector, I'm writing it as VQ, vector quantities. Direction is significant or it is must. Right? Yeah. So this is an important point. Third one especially, that scalar may or may not. Sorry. Yeah. Scalar may or may not be, have direction to solve quantities, but vectors we always need direction in this case. Okay. Right. I think we got all the 3 points. Now, if you look at the example, what are these? Let's just see. Some examples of the scalar, as we just did the earlier, it's the distance, time, and many more. And for the you know for the vectors, the example is displacement and its velocity and its acceleration and all. Okay, I think you got it. Now we have seen the difference between scalar and vector as well. Now we'll be looking at how do we represent a vector or the representation of a vector. Right? Yeah. So vector could be represented by in two different things, which are, first they can be represented as analytically, and other one is graphically. Right, yeah. So let's see how we can just represent them. First of all, analytically we can represent any vector as v vector or a vector or a vector, anything force. So here, as you can see, this arrow over all the vectors, we use this as a symbol or the notation for the vectors. Or in some books like Erudova and all, you can just you will be looking at the vectors are the in the printed in bold letters, so that is also representation. But generally we'll be dealing with all these arrows for the vector representation. And this is a vector, okay. For magnitude, what do we do? Let's see. So we represent the vector's magnitude by, sorry for this. Yeah. So if we write it like this, these bars or the logs which we have locked the vector inside, it's nothing but the magnitude. How do we represent the magnitude of a vector? And in this case, it's v or the velocity vector. The magnitude would be like this. So let's just see example, which is our favorite thing. Now, if we take example of both these representation, right? If suppose let's say I write force is equals to 12 Newton towards east. Yeah, so this is the force vector, right? Because I have represented it with an arrow. But the magnitude, as I've told earlier as well, it is represented by caging it inside a bar. Two bars are there. It looks like it's in a cage. I'm just sarcasm me. Now, let's just see. So here it would be 12 Newton only, because it represents magnitude, and we all know that magnitude is the numerical value plus unit. So here we would not say it east. We would not represent east here, because we know that it's the magnitude and it doesn't show any direction, right? Yeah. Now this was the analytical part, right? How do we represent a vector analytically? We just say. Now if we look at the other part, which is nothing but the graphically. So so in case of the graphical, how do we present it? So it's nothing but the first thing you have to remember that its magnitude is directly proportional to the length of an of arrow. I'm gonna tell what I'm gonna talk about. Just a second. And the other thing, direction. Sorry. Yeah, direction is also directly proportional to direction of arrow. Right. So what I mean by it, let's just see. Yeah, so here it's nothing but like, let's see, I've drawn an arrow like this. It's a vector. Let's suppose it's a vector, and it has two parts. One, this part which I'm highlighting, it is known as the tail of a vector, and this part which I'm highlighting, it is known as the head of a vector. And this the distance or the path or the white path which I have drawn here, it represents the magnitude. Okay, so let's just clear this one more time. Like you have not understood what is this all which I have written over here. Let me explain. Right, so in this we saw that there's a head and a tail, right? So this is a graphical representation of vector in which we draw an arrow in the direction, right, in the direction of a vector, in the direction which is given. The direction of arrow represents the direction which is given in the question. Suppose let's say if it is given east in a question, so we draw an arrow like this, okay, in the east direction, simple Cartesian plane. And if it is given south, we'll draw it like this. If it is given as southeast, we would draw it like this, okay. And this, the length of a vector, this thing which I'm highlighting here, is nothing but the magnitude, how much magnitude is. Suppose, let's say, if a particle is going 2 kilometer in the south direction, like 2 kilometer, so this we have to draw it as 2, not the kilometer exactly, we don't have all that tools. So we can take it anything like 2 millimeter, 2 centimeter, or even 2 kilometer if you can arrange it. But in general, like, let's assume that it to be 2 centimeter, right? So if it is in east direction of 5 kilometer, let's say, we have assumed 1 kilometer, or the 1 unit is equals to 1 centimeter, so it would be 5 centimeter. So the length of this, the arrow should be 5 centimeter, which represents the magnitude. Okay, so let's just clear this one again. If we say that, right, this is a vector of 2 unit, so this would be of 4 unit. See, if this is x, then this is 2x. X you can take anything like centimeter, meter, or anything, okay. Let me write it 1x, okay. So I think you got it, like how do we represent. Let's just see again how do we analytically. We are gonna deal mostly analytically in this chapter. So we just draw an arrow over the symbol like velocity, acceleration, and all. And for the magnitude, we, that put it inside a cage or a bar, or we put 2 bars in either side of the vector. So it's the magnitude, and it doesn't have any direction. We just represent it as 12 Newton for this case. And graphically, as I have mentioned here, as I've mentioned there, the magnitude here, it's directly proportional to length of an arrow, which means if the length of an arrow increases, the magnitude also increases, or it shows that magnitude has increased. And for the direction of an direction is also directly proportional to direction of arrow, which means the in the direction the arrow is pointing, the same direction is the question, or the same direction the vector is in. So I think you got it. So that's all for today from my side. Hope you loved it, and I've uploaded some questions for you to solve. Check them out in the description, and I'll see you in the next part. Till then, see ya and take care.